So this is the agenda that we are primarily looking at. When it comes to the monitoring, we will look at monitoring services which are available in Google Cloud, which includes monitoring, auditing, logging services in Google Cloud, and profiler and tracing also, which is Ops Agent setup and configuration. We'll configure Ops Agent for both Windows and Linux virtual machines. If you wish, you can deploy a sample application, probably an Apache web services, and then we can see how do we configure Ops Agent to monitor an Apache web services and monitor for various requests that comes to the web browser. And we can do the same thing with Internet Information Services in uh, in a Windows client or server based operating system. We look at observability in GCP. We look at synthetic monitors, which is nothing but application performance monitoring. We'll also look at the monitoring aspect for PaaS services, which includes App Engine, standard and flexible plans. So we'll see what all monitoring capabilities are available when it comes to PaaS, because PaaS basically means that infrastructure is being managed and maintained by the service provider. So you have a very little play there when it comes to the management, maintenance, and monitoring. But whatever is available when it comes to a non-VM instance, which is a PaaS service, what all we can monitor and what all we can configure, we look at it. We look at profiling, and we'll also look at some additional topics that I primarily feel that you should be aware of based on based on the project that you're currently working in, as well as the projects that you are expected to work in near term. Then comes database. So when it comes to the databases, we look at Cloud SQL, Cloud Spanner. I'll see if I can include BigQuery. uh, so I'm not too sure if I will be able to include it at this moment, because that is a paid service and we will need to look for lab part for that. But I'll try and include the BigQuery part also. So we'll look at Cloud SQL, Cloud Spanner. We'll look at databases that you deploy on the top of a VM, or bare metal databases. We'll also look at some concepts with respect to the backup and disaster recovery, backup and disaster recovery of databases, of instances, of services that we provision in Google Cloud. We look at encryption. So encryption is something that we have already covered. However, so I would request you to look at the session recording wherein I'm covering the cloud KMS with the cloud storage bucket, and you can come back with questions, or I can spend a couple of minutes covering that topic from, covering the encryption topic from database perspective, that how do you encrypt a Cloud SQL, which is based on Oracle, Microsoft SQL Server, or any open source database using Cloud KMS? How do you configure the encryption? How do you configure the data protection, transparent data encryption, or best practices around it? So that's what we will do. How do you access the data by supplying the encryption keys, and the various aspects of management, monitoring, maintenance, logging, and network configuration around IIS and PaaS services. That's what we are going to cover, which is equally important for the other team members. It is not only meant for database, it is meant for everyone. And then in the end, we'll also see the migration of servers from on-premises to GCP. So we don't have an on-premises environment, to be honest with you. However, we will provision an on-premises replica into another cloud service provider, which is Microsoft Azure or AWS Web Services, Amazon Web Services. There I will configure a couple of virtual machines with pre-configured applications, and then we will see how do we migrate those virtual machines from Azure or AWS to Google Cloud. What migration solution do we use? How do you plan the migration when it comes to migration from, when it comes to migrating a server in the form of a compute engine instance, or when it comes to migrating a database running on a server directly into Cloud SQL. So we'll look at those aspects. So we'll understand the migration both from infrastructure as well as database perspective also, so that it makes sense to rest of the participants also who are not part of database team, but they would like to understand the migration aspects from servers and application perspective also. So that's the agenda for the session that I have received. This input I've received from your management based on the projects and requirements that you're currently working at, especially what they predict and foresee requirements coming to your team in near, in the near and long term. So that's about the agenda. Do I have any participants who has any additional questions or who would like to provide some inputs in terms of any additional service that you would like me to include here? Because we are trying to finalize the scope before we get started. So I'm open to suggestions and inputs from the participants from PMC and database team. Let me know if you want me to include any additional service here so that I will have it included and I will have it delivered and then create a delivery plan around it.
Yeah, Raghavir, coming to the database part, in Oracle, there is a concept of a rack cluster.
Okay.
Means there will be two servers which will use the same storage. Like node 1, node 2 means server 1, server 2 will be there. And these two servers will share the same kind of storage for the database functionality. Okay. So these two servers will communicate with each other through a private IP. I can say as a private IP, not a public IP. Yeah. So please include that how we can deploy the private IP. And there is a one more concept called a virtual IP will be also there. Virtual IP. So how these IPs we can configure in the GCP.
So that virtual IP is the private IP actually.
Sorry?
That virtual IP, I'm saying that private IP basically belongs to the instances, and virtual IP is the IP on which the communication happens. It's also known as network load balancing or load balancing the storage services, so that at any point in time, it has the same data. Both the servers are reading from the so I would say in a layman terminology, you can understand that the storage will be provided a virtual IP to which both the instances will be connecting with.
Yes.
Yep. So deploying via virtual IP as well as monitoring aspects.
Okay.
Right?
Yeah.
I've made a note of it. Anything else, guys?
This RAC. The name is RAC.
Yeah.
Okay. So Raghuveer, we do have our data center, right? We can create one VM and then that VM can be migrated to GCP.
Absolutely, you can do that.
Database. We do have on-prem data center.
Yep. So I don't have access to your on-premises data center. However, if you have access to your on-premises data center, what you can do, you can ask your IT team to provision a server for you. Basically, get two servers provisioned, not one. One Windows and one Linux, so that you understand the migration aspect from both operating system perspective, right? And if possible, ask your team to grant you access to those servers so that you can also deploy sample applications on it. You can deploy web services on it. You can probably deploy a sample HTML page, ensure that the server is accessible over the internet, and then do the migration and then validate for yourself that when it comes into GCP cloud, when it turns out to be a compute engine instance, is there any additional settings or configuration that you need to do, or the migration tool itself takes care of everything. So that's a good idea also. But this is similar to provisioning it in Azure and in AWS. It is the same case. It hardly makes any difference. Your IT team will not give you a physical server. They will probably give you a server virtual machine. Now, whether you provision that virtual machine in an on-premises data center or whether you provision it in a cloud, in any other cloud, it's one and the same thing. It hardly makes any difference from the configuration perspective. But I leave that decision to you. I'm saying you can do that in addition to what I will be covering. You can also get that server provision for yourself, and then I'll tell you how do we make use of my Google Migrate for Compute Engine solution that we use in Google Cloud for migration of on-premises workloads and applications to Google Cloud. That's what I will explain you with. Okay.
Sure. Thank you.
Yeah. All right. Any other participant? Do I have any inputs from PMC team? These inputs were related more from infrastructure and from database perspective. Any input from PMC team? If you are currently supporting monitoring for Google Cloud deployments, you probably have come across certain issues, or you probably have come across configurations that you have not yet tested, you have not seen in the current project. If you would like to talk about them, I can include them and I can also have them delivered in the training session. So this is the time when you can provide inputs. All right. Let's get started. If you don't have any additional inputs, I have made note of these two inputs from Madan and Hemant, and I will make sure to add them into the agenda. Okay, let's get started, guys, then. So to the other team members, we basically covered the compute service. So we basically covered all core services, which includes VPC, IAM, storage, uh, and then we were at compute service. So this is the presentation that I basically used. The session got recorded, so you can see the entire session recording. I'll just take 2 minutes, probably 5 minutes to cover this part. This slide I would like to cover, and then we will directly get into the provisioning part because that's where we left the session. So when it comes to the compute services in Google Cloud, these are the options that we have with us. We have a popular service, which is most widely used, 90% of the customers use, which is Compute Engine. This is similar to a virtual machine or a physical server as we use it in any on-premises data center deployment. So we have Compute Engine, which is similar to Azure Virtual Machines, AWS Elastic Cloud Compute or EC2 instance. And this Compute Engine virtual machine, this basically supports all languages. This falls under IIS, Infrastructure as a Service. And as I say, it falls under IIS, it basically means that the customer is responsible for all the management and maintenance, which includes monitoring, patching, update, managing the life cycle. Customer is responsible for it. Google Cloud is just providing you a virtual machine with pre-configured resources in terms of CPU, memory, type of storage that you have taken, whether you've taken premium storage, standard storage, balanced storage, and you're responsible to manage it. This supports auto scaling, and this we primarily use for general workloads. When I say general, it includes both production and non-production environment. Then comes Google Kubernetes Engine. This is another service, another compute service in Google Cloud, which is similar to Azure Kubernetes Service, AWS Elastic Kubernetes Engine, wherein you will deploy containerized applications. And to manage and maintain and orchestrate those containers, you will be using Google Kubernetes Engine, which is a managed container runtime. So it's a managed container services that we primarily use. In what scenarios do we use it? We also use it for general workloads. However, primarily for applications which are built based on microservices architecture, wherein an application can be broken down into smaller microservices, and each microservice runs independent of the other. So we primarily use containers. So we package those microservices or applications into a container, and then we manage those containers using Kubernetes Engine. That's what we use GKE for. Then comes App Engine. App Engine has two environments, standard and flexible. These are two SKUs of App Engine, and it's a pure play PaaS service. When I say PaaS, Microsoft manages the, I'm sorry, guys, so sometimes I get confused. I use terminologies of other cloud because I deliver trainings on all the three clouds. And sometimes it happens that I'm finishing a training session and joining this training session. So when it comes to App Engine, this is similar to Elastic Beanstalk in AWS and Azure App Services in Azure. Now, what happens here? Google is responsible for managing the underlying infrastructure, which includes high availability, fault tolerance, resiliency, which includes patching, monitoring, all that Google does. And a customer is primarily responsible for managing the application that you are hosting in App Engine environment, as well as the data that application creates, processes, stores, and manages. And customer is also responsible for managing the identities in terms of who will be granted access to those applications in the App Engine environment, and also is responsible to configure some security controls with respect to the access criteria, with respect to the identities. So that's what customer does, plus some bit of monitoring that you are capable of enabling. So you can also enable the performance monitoring, the synthetic monitoring for those applications which are hosted in App Engine. So App Engine supports multiple languages, and it is a pure play PaaS service. As I said, you can use it for scaling applications. You can use it in a scenario wherein you don't want to manage the infrastructure overhead. You want Google to take care of it. And you can use it for scalable web applications, mobile backends. I'm saying these scalable web applications, mobile backends can also be very much hosted into GKE in Compute Engine and the other options also. Then comes Cloud Functions, which is a serverless service. And this is also used for lightweight event-driven applications for microservices architecture for sure. And when I say it's serverless, it basically means that the resources are allocated to the application when there is an event that occurs. So when something is executed, the resources are allocated on runtime, on demand, and when that event is done, when that execution is finished, resources are taken back. That way you manage the cost effectively. And this is another option that you can pick and choose. It's like giving you multiple varieties. You pick and choose what is most appropriate for you, considering the workload that you are willing to host, as well as your budget, your cost and your budget, whatever your pocket allows. So that's the option. Then you have Cloud Run, which is another option, which is an advanced, or I could say a substitute for GKE. A GKE is server based. Here you create clusters of worker nodes. And in Cloud Run, you don't create clusters of worker node. It's a serverless service. So you do the same containerized application deployment in Cloud Run. However, resources are allocated at the runtime. So GKE is server-based and Cloud Run is serverless. That's the only difference. Rest of the capabilities are same in both the services. In GKE, you manage, you control. In Cloud Run, let Google control the resource allocation and utilization. So these are the compute services that we have in Google Cloud, and we are primarily focusing on Compute Engine today. I will show you how do we provision a Compute Engine instance for both client and server operating system. And then I will also show you all the options that we have while you provision the instance. You can also provision, you can also practice in your respective account the same concepts. We'll also deploy probably, we'll also see how do we deploy applications and understand the networking part of it. So that's what we are going to do. Any questions before we get into the provisioning? No. Great, let's move on. So I already have logged into my environment. So this is the project that we are using. So let me log in. So the first thing that you need to do is to select the right project. After you select the project, you navigate to Compute Engine. You can also search for compute here in the search bar. That's also available. You can type compute and you see Compute Engine option here, or you can also click on these three horizontal line that opens a drop down. From the drop down, you can select Compute Engine, and then under virtual machines, you can click on VM instances. That's what you can do. So I already have a VM instance running, which I was primarily using for one of the webinar that I delivered today in the afternoon. So I'll go ahead and provision a new instance. Now let's look at the options that you come across while you provision an instance. So we'll hit on create instance. Let's look at these options very carefully while the session is getting recorded, so that even if you're not able to comprehend it in the very first attempt, you will have this session recording available to you that you can reuse, watch it all over again, and make sure that you understand it. So when you provision an instance, we will provision two instances, as I said, one Linux, one Windows, and we look at the connectivity options. So the first thing is to provide the name of the instance. This is where you provide the name of the instance. So I'll say this is my testing. I'll provision Windows and then Linux. Testing Windows. Then comes the region for this instance. You know, Google Cloud is a global cloud service provider. It has multiple data centers across multiple geographies, multiple parts of this world. So we need to choose a region. Region is a geographical boundary where it has a collection of data centers, clusters of data centers, wherein your instance will get provisioned based on the subsequent settings that you select. So you can select the region. I have a VPC configured in the previous session in South Carolina. That's a custom VPC. So I'll select that region. Then comes zone. Zone is a cluster of data centers which are configured for high availability perspective, wherein those clusters of data centers are connected with one another through high speed optical fiber cables, and they are capable of holding redundant data. So you have in South Carolina, US East 1, 3 availability zones, which means there is a 3 cluster of data centers. How many data centers are there in each cluster? Google doesn't make that information public. However, from the logic, you can understand that there has to be a minimum of 2 data centers in each cluster. So I can say any. If I say any, Google will choose one of the zone randomly. Or if you want to identify earmark a zone, you can select it. So you have B, C, D, 3 zones. I can select B here. Zone is permanent. You will not be able to move your virtual machine from this zone to any other zone. That's what you need to remember. You can definitely move this virtual machine from this region to another region within North America. You can even provision your virtual machines or copy your virtual machines or recreate it in any other region outside of North America as well. You can re-provision it in Europe, in Asia Pacific, in Australia and New Zealand. That's very much possible. But changing the zone is not allowed in Google Cloud because it basically creates a tag. It tags that machine to that specific data center, and accordingly resources are allocated. So it's permanent. Then comes machine configuration. When I explained the compute engine theoretically, I did talk about various machine types which are available, machine families, and machine sizes. So we have 5 families, which is general purpose, compute optimized, memory optimized, storage optimized, and GPU optimized. For this demonstration, I will use general purpose, and to optimize the cost, to reduce the cost, I will use E2. And in fact, in E2, since this is a Windows VM, I need to take reasonable configuration also, so that I can connect to this VM and deploy services accordingly. So I will go with E2 medium, which provides me 2 virtual CPU cores and up to 4 GB of memory. So that's how I can select the VM. Now, if you remember, when we covered the theoretical aspects, I did talk about that other than providing pre-configured sizes or pre-configured instances, Google also provides you the capability to pick and choose the configuration by yourself, keeping in account the compatibility part, which basically means, as I told you, that you cannot pick up a configuration which has 2 CPU cores, which has, let's say, 4 CPU cores and 1 GB of memory. That's not possible. There has to be a minimum of 1 GB of memory for each CPU core. That's how you can do it. So that is where this option is, which is custom. You can hit custom, and here you can pick and choose the CPU cores and memory. So right now you can say it's going for 2 CPU core, 1 GB memory, which is not the right configuration. It may have performance impact, or this VM provisioning may not succeed properly. So you can probably increase it. You can say instead of 1, I need 4. So 2 virtual CPU cores and 4 GB of memory, 4 GB RAM you're taking here. So I'll go with the preset. I was just trying to show you that where exactly that configuration is. You also have advanced configuration option here, wherein you can also select vCPU to core ratio and visible core count. So let's just go back to the preset and let's go with this configuration wherein I'll get 2 CPU core, 4 GB of memory. I'll move on. Next is availability policies. When it comes to availability policies, you can see we have 2 policies, standard and spot. I did talk about it in the theoretical session. Standard basically means you own the virtual machine, you manage the life cycle of the virtual machine, and Google will not take it back from you upfront, accidentally, automatically. It belongs to you. It belongs to the customer. It will remain with the customer as long as customer wants to make use of it, leverage it. Spot, ideal for fault tolerant workloads. When you are doing some POCs, when you're working on some temporary project, wherein you don't bother about losing data, losing access to virtual machine, you can go for spot also. When you select spot, you will see whether spot instances are available in that region. If they're available, then you can select the time frame which is available, and you can take the instances accordingly. So I'll just go with the option that we primarily go in production environment, standard. Okay, so we are selecting standard, and since it is still taking the spot part, let me refresh it. Okay, so we'll not configure this option. I probably need to refresh my screen now because the screen is not refreshing after I switch from spot to standard. And this primarily happens during this time. This is the beginning of US EST business hours. My virtual machine is getting provisioned in US. This portal is also configured in US. So sometimes the synchronization or refresh issue happens. So I'll select the configuration once again. Testing windows. I'll select my region. Zone, I can select B. Moving on, general purpose. I'll go with E2 medium, which is 2 virtual CPU cores, 4 GB of memory. VM provisioning model will be standard. Moving on, you can enable display device that will help you to capture the screen and recording tools. So we'll not enable any additional service that will have commercial implications, but I will explain you what that service is. Similarly, you can enable confidential VM service. Confidential VM service basically means that it will have secure boot and trusted platform module capability enabled that will protect your virtual machine from boot sector or boot level security incidents. So your virtual machines may not encounter any malware or a ransomware that can capture the boot sector and probably leave you out of the virtual machine or kick you out of the virtual machine. So you can enable this, but anything that you enable over and above the default options will cause you additional budget. So we are not enabling it. Then we'll move on to the next, which says container. If you want to deploy a container image to this VM instance, you can select here and you can do that. So we'll just move on. Then comes boot disk. Now you need to select the boot disk here. Boot disk basically means the root drive that will be attached to the VM plus the operating system image that it will contain. So I'll click on change, and here I can select. So I have public images, wherein the images provided by Google. I have custom images, which basically means the images that I can build myself. So typically corporates use golden images or default images wherein they deploy an operating system. They deploy all required applications, configure them to the best practices uh, of the corporate, of your global policies, and then they create an image from it. They upload that image here, and they use that image to deploy virtual machines in cloud, be it Azure, AWS, GCP. And the advantage of that approach is that those virtual machines will be hardened as per the corporate security policies. And you don't need to manually deploy those security solutions time and again on newer virtual machines in future. So that's custom image. You can also deploy uh, deploy a compute engine instance using a snapshot. You can take snapshots of root drive and then use those snapshots to provision the compute engine instances in a scenario wherein you are experiencing some data loss you're experiencing some connectivity issue with your instances, and you've tried everything, it did not, it was not successful, and now you have point of no return. So when there is point of no return, and luckily if you had backup, if you had snapshots, you can primarily use those snapshots to rebuild your virtual machines with minimal or no data loss. So that's what snapshot is. Same is the case archive snapshots and then existing disk. If you had a virtual machine in the past that you had to get rid of because you wanted to save cost, it was not needed, but you preserve the disk of it. You preserve the root disk. So if you had done that in the past, you can now, this is an opportunity for you to use that disk and reprovision the virtual machine. So these are my options which are available when it comes to boot disk. Now what I'm going to do, I'll select a Windows operating system here, which is, so Google Cloud doesn't provide you client OS from Microsoft. It only provides you server OS. So I'll pick up the server OS, and it also doesn't provide Windows 2012. It starts with 2016 and above. So I'll go with 2016 data center. The difference between data center and data center core is core basically means no GUI. It will not provide any graphical user interface. You will be presented a black screen similar to Linux, and you will be interacting with the machine using the commands. So I'll go with 2016 data center. Boot disk. I did talk about it in the storage as well as in the virtual machine session. So we have four options here. Balanced persistent, which basically means it has a balance of input output capabilities. In cloud, we use the terminology of IOPS, which is equivalent to disk read byte per seconds and disk write byte per seconds in on-premises. So IOPS stands for input output per second, which basically means the amount of request, read and write requests that my machine can handle, that my disk can handle, every second. That's what IOPS is. And then comes throughput. Throughput basically means that what will be the maximum amount of data that can be read or written to the disk every second. That is known as throughput. And that is calculated in megabit per second, MBPS. So IOPS and throughput are the two factors basis on which you can identify the capability or the viability of a storage service or disk. So we have balanced persistent, extreme persistent, SSD persistent, and standard. Standard means magnetic, not more than 500 IOPS read-write request per second, and you can probably use it for non-production or some POC specific projects. For production, I would suggest you to go with balanced or extreme persistent or SSD persistent. So we'll go with the default option, which is balanced persistent. You can compare the disk type also if you want to compare it. Here you can see, you can select a size here and you will see the capability that it will provide you in terms of IOPS, read-write IOPS, and throughput. You can see those two factors, read-write IOPS and throughput. So throughput and IOPS are the two factors to the disk, two deciding performance factors for a disk. So I'll go with balanced. Since I've selected Windows, typically what it does, the moment you select Windows, it changes the size of the disk to 50 GB, which is the default size. It did not change probably because of synchronization, so I will make it 50. Because a Windows operating system compute engine instance requires a minimum of 50 GB of space on the disk, and you can always increase it. However, you cannot shrink it or decrease it because cloud service providers do not allow disk shrinkage or disk. You cannot scale it down. You can always scale it up. And why they do not allow? Because it may corrupt the files. It may corrupt the application. So they don't allow it. You can see advanced operations, which basically relates to encryption. How do you want to encrypt this disk? Right now, we are going with the default, which is let Google manage the encryption key for this disk. And you can also select a snapshot schedule. If you don't select anything, it will not configure the snapshot for a VM. Before you select a snapshot schedule, you need to create it. And from the snapshot view, then you can select it here. So I'm just going with the default options here. So that's what you do. I've selected it. Now it has taken it. So you can see now it has increased the monthly cost of this VM, which is now $63.04. Why? Because I am using a premium image. So they're charging $33.58 per month for this image. This premium image is Windows Server image for which Google is paying to Microsoft. Okay, let's move on. Guys, if you have any questions so far, please ask me, else I'll make a move. Okay, let's move on. So when it comes to identity and API service, which is the next option, so what is happening here? Basically, in cloud, when you connect to a resource, you basically authenticate and authorize. So how does a user or an identity, in Google terminology, we call it principal, how a principal connects to a resource in Google Cloud, and what permissions the principal has, that is decided by IAM service. So for every service in Google Cloud, there's a default service account, which is used when you do not define any custom account. So by default, it will use a compute engine default service account, and that default service account will have access to all the capabilities by default. However, if you want additional capability, you want your virtual machine to be able to access all cloud APIs, this is the radio button that you can select. When you select the second radio button, it basically means that your virtual machine will now have access to all Google Cloud APIs. And when I say APIs, it will have access to all Google Cloud services, additional services that require authentication and authorization. Your machine will be able to authenticate and authorize to those services. The example is Cloud Storage Bucket. Your machine will now have full access to Cloud Storage Bucket with this, which is a very risky setting that you can choose, which is not recommended in a production environment. So what you should have selected instead, you could have selected set access for each API, and this is where you will see all the services of Google Cloud that has API based, that has APIs available, and you can basically select. By default, it selects none. So let's say you want this machine to be able to communicate and collaborate with Cloud SQL. You can select Cloud SQL. If you want this machine to work with any other Google service, you see all the services listed here. You can just select those services and the machine will have access to that service. That's the concept of access. So by default, we'll go with the default option, which is let's allow default access. Now, similar to this is private Google access from VPC perspective. If you remember, when we were doing VPC, I did talk about private Google access. What does that mean? That basically means that machines that do not have a public IP, they will not be able to communicate with any Google service that has a public endpoint, like Cloud Storage Bucket, Cloud SQL, BigQuery, Cloud Spanner, Cloud Run. Machines will not be able to communicate if they don't have a public IP. But when you allow private Google access, Google will create a separate route for those machines, for instances which are part of that subnet, that subnetwork, and they will be able to communicate with Google Cloud services using their private IP address. That's what private Google access is, and this is identity and API access. So this is different from that. However, both services, you need to exercise caution while you enable it, because those services may increase the attack surface area of your network. Okay, so we'll go with the default access right now. Let's move on. After this, firewall. Now, if you know well in advance that you're going to use this virtual machine to be as a web server, and you would like to host some web application, some portal on this virtual machine, and for that you want the specific ports to be whitelisted in the VPC firewall where this virtual machine will reside, this is your configuration. So you can say allow HTTP traffic, you can say allow HTTPS traffic also. Or you can use another capability, which I talked about in the VPC security session, what do we call it? Rakesh, what is the other option? Wherein I can whitelist a port and I can have this VM accessible on that port.
Okay, in BPC network security group, the firewall rules we can enable.
What? That is network tag. That's the concept. Remember, I did the entire section on networking tagging with a use case. Okay, yes. That's network tagging. So if you don't want to allow HTTPS traffic from here, that will create a separate exception into firewall rule. You can probably use a network tag. So let's say I will not say allow HTTPS and HTTP here. And if I don't want load balancer health check, which basically means if this VM is not going to be hosting an application that will get load balanced using a load balancing service, you don't allow anything. Then comes observability part, which is the monitoring part. Google uses ops agent. Ops agent is nothing but a small executable file that gets installed on the workloads, and it has the capability to monitor the workloads for performance and availability monitoring. So it can quickly monitor the workload, CPU, memory, disk, process utilization. It can monitor application utilization. It can monitor for logs also. If you want to collect event logs from the machine, it can also do that. So it's nothing but a monitoring agent that gets installed. So you can deploy the ops agent directly by selecting this checkbox. And at the time of provisioning this VM, the ops agent will be deployed. Or you can do that manually also. You can download the ops agent and you can manually install it on the VM also. So both options are available here. So I'll not do that. I will cover this ops agent part in detail in the monitoring session. Let's move on. Then comes advanced options. Now, so far you've not selected the network. And if you have not selected the network, it means this VM is going to be built or dumped inside the default network, something that we don't want. We want this VM to get hosted in a network of our choice. That is where under advanced option, you have networking service. So you can click on networking, and this is where you will choose all the networking features. So it starts with network tag. You can select a network tag if there is any from here. Then comes network interface card. Don't select it. Don't enable IP forwarding. You can select the host name also for this VM. By default, Google will pick up this host name, which is the name of the VM - US East 1B, which is the geography, then the availability zone, and then the project name, then GCP training project name .internal. That's the host name. If you want to change it, you can change it. This choice is permanent. You will not be able to change it later on. Network bandwidth, leave it. The most important part is network interface, where exactly this VM will be hosted. So this is where you select. It says network interface as default. So if I had not selected this configuration, the VM would have been provisioned into the default. I'll select my own network now, something that I created in the previous session, which is testing custom VPC. And here I can select subnet. There is one subnet with the name production that I'll select here. Then comes the choice of having IP address. Now, by default, Google will allocate the VPC has DNS and DHCP capabilities. So VPC will allocate a private IP from the address space that has been allocated to the subnetwork where this VM is going to be residing. However, if you need a public IP on the VM for some specific requirements, you can also select it here. By default, you can see it is selected. Primary internal IP address is ephemeral automatic, and you can see here, which is IPv4. So this is by default selected. If you don't select it, I'm saying you can do custom also. When it comes to custom, you can select your custom IP address also. And when it comes to external IP addresses, so here this is internal, which basically means if you want to put a static IP address on this VM, you can put that IP address from here. I'll just go with automatic so that Google assigns it automatically. Then comes external, which is public IP. It is picking up a ephemeral IP address, which is static public IP. If you don't want, you can say none. This ephemeral is not static, it is dynamic allocation. However, you can click on reserved static IP address, and whatever IP address will be provided to the VM will be static to the VM throughout its lifetime. Whether VM is running, whether the VM is stopped, the IP address will be reserved on the VM. So that's the concept. Network service tier, premium is by default selected. Google wants you to pay more. This basically means that how quickly the network experience will be. You can always go with standard. It provides you 200 GB per month in each region, which is more than sufficient for communication. In fact, customers use in production, customers use the same standard tier. They don't go with premium unnecessarily. This is PTR records, which is the pointer records. You can also enable reverse DNS lookup. Right now, the DNS lookup will be forward, which means VM's host name will be resolved with the IP address. But if you want to configure reverse DNS lookup, which is IP address to host name, you can enable for IPv4 and provide your PTR domain name, which is your domain name of the domain name, Active Directory domain name that this VM is going to be joining. That's what you can provide here. So I'll just uncheck this box because we don't have a domain name here. We'll move on. Then comes disk. Here you can add additional disk to the VM if you wish. If you have intention of putting additional files, additional data on the VM, you can add additional disk on the VM, which is like D drive, E drive, F drive, wherein you can put your application, wherein you can put your business specific data. You can create a new disk and attach it simultaneously, or you can attach an existing disk to the VM also. You can add local SSD also. Remember, I talked about local SSD in the last session, which is a physical drive from the host that is connected to the VM. Now, this option is faded, which means this VM family, this VM size doesn't support local SSD. Then comes security. So it has by default, we have enabled turn on VTPM, which is trusted platform module. I can also enable secure boot. Now, some VM families do not support secure boot. So if it doesn't support it, you will get the error when you hit create. You have integrity monitoring turned on, which basically checks for boot sector integrity before it loads the operating system. Okay, VM access. So it says manage how users connect to the VM. It says by default, when you connect to a VM using the console or G Cloud, your SSH keys are generated automatically. So this is for Linux. But what about for Windows? For Windows, it will give you an opportunity to select the password, the local admin password. And once the VM is joined to a domain, then you don't need that local admin password ever. You will always use your domain credentials, your domain admin credentials to have administrative access on a domain joined VM. So here you see manage access option. So you can block project-wise keys. You can manually generate SSH keys. So we'll just go with the default options. Okay, then comes management. In the management, you have some additional settings that you can configure, which is you can enable delete protection. Nobody will be able to delete this VM unless this protection will be disabled. So this will protect your VM from accidental deletions. You can also create reservations. You can enable metadata. So these are all the options which you have. Then comes data encryption. By default, we are going with Google managed keys. We are not using cloud KMS. So your virtual machine and the disk will get encrypted using this encryption method. Then comes sole tenancy. Google also lets you create virtual machines on physical servers on hardware, which is known as bare metal hardware. So this machine type is not eligible or compatible with sole tenancy. That's the reason that option is not enabled. So that is where I have explained from top to bottom all the options that you come across when you provision a compute engine service in Google Cloud. I'm open to questions if you have any before I hit create, because after I hit create, I will lose this window.
Sir, that you told about this firewall, like it is instance, like VM level firewall, and the BPC that it is an subnet level firewall.
No, it is the same firewall. It is the same firewall. So what it basically does, it will create an exception in the firewall It will tell the firewall that for this VM, the HTTPS and HTTP traffic will be allowed, depending on the checkbox that you select. You can see here, it says by default, all incoming traffic from outside a network is blocked. And where it is blocked on the firewall, VPC firewall. So this setting will create an exception in the firewall to allow traffic on port 80 and 443 for this virtual machine. That's what this setting is all about. And that's the reason I did not check it, because I wanted you to use or leverage the network tag concept, which is the right approach in a production environment.
Okay. So then if you want to override this one, we need to go with a less priority, like check with the less priority rule.
No, what you actually need? Do you need HTTP
yeah.
access to VM or not? That's the question.
Here I enable the HTTPS, but in VPC firewall, if I go and create a firewall with less priority, then it will override this one.
Obviously, because when you enable this, you will see a rule in the firewall. So I'll show you. So I'm enabling it, right? I'll enable it, and then we'll go back to the firewall and see what changes will happen in the firewall because of these two checkboxes that you have just enabled. Okay, great. Any other question from any other participant? All right, let's move on. I'll hit create now. The virtual machine will get created. What happens in the backend? You've just selected some configuration from the UI. Now this configuration will be consolidated, will be sent in the form of API to Google Cloud backend, who will then pick it up, process it, and that will result in a virtual machine getting reflected under VM instances blade. Now, this virtual machine says its status is green, which means it is up and running. You can see the internal IP, you can see the external IP of the virtual machine, but it doesn't mean that it is right now available. It's a Windows server that you've just provisioned, which will definitely take 3 to 5 minutes to get provisioned. If you try to access it now, it will not be accessible. There is no point of wasting time in doing that. So it will not be accessible actually. However, how do you know that it's a Windows server? The name will not tell you ever, because I have intentionally put Windows here, but in a production environment, you will probably not have an identifier in the nomenclature, which will tell you the OS of the virtual machine. So Google tells you, if you see RDP against a VM, it means it's a Windows server. If you see SSH against a VM, it means it's a Linux server. That's a way to check or to identify whether it's a Windows or Linux. The other way is, once this instance is ready, you can also select this instance, go to its properties. It will tell you the operating system that it is holding. You can see the operating system here for the instance. When you scroll it down, you will see the operating system here, which is under boot disk. It says Windows Server 2016 Data Center. That's the operating system. So you can also see it here. But on the main blade, by looking at the connectivity options, you will know whether it's Windows, whether it's Linux. Okay. So let's connect to the VM. How do we connect to the VM? The first thing is RDP. We need to click on RDP. It says connect using your RDP client. Now we can download the RDP file. The drawback of RDP file is, since we have selected ephemeral IP address, it's dynamically allocated. The same RDP file may not remain valid tomorrow or day after, because they release and renew the IP addresses every 24 hours unless it is static. So unless you have a local connectivity from your network to Google Cloud VPC where this VM is hosted, this RDP option will not be suitable. However, we can download it. This is how it will download it. So the RDP option is, RDP file is downloaded on the system. It is here. It's testing Windows RDP. Then comes the password part. So you can click on this arrow this down arrow which says set Windows password. You can also see G Cloud, which is the CLI of Google Cloud, to reset the password. You can download the RDP file here also, and you can learn about Windows authentication, which will take you to Google documentation, wherein it talks about managing and maintaining Windows-based client and server compute engine instances. So I can say set Windows password. Now, when I say set, the username is already given. In a production environment, you only use this capability once. The moment your VM is joined to the domain, it is the domain credentials that you will continue to use. Or you will use a solution like CyberArk, ForgeRock, SailPoint, Okta, or any PAM solution, privileged access solution, privileged access management solution, where the VM will be uploaded and users will be authenticating to the VM from that solution by not providing the credential, but by having their access aligned in that solution. So you can click on set, and here you will get the password. You can also change this password after you log into the VM. You can go to local users and group and change the password also. So this is your new password. You can copy it because we need this password to connect to the VM. We'll copy it and we'll store it. So the password is stored. Now I'll close it. After that, I can double click on the file that I've just downloaded and see if I'm able to get the connection prompt, which I'm getting here. You can see by default, it picks up the username because it's embedded into the RDP file. All I need to do is type the password. So I'll type the password and hit OK. This is how I can connect to a compute engine instance that you provision in Google Cloud. After you are connected to the instance, after it is loaded, then it will be the same operating system that you see in a virtual machine, whether it is in any other public cloud, whether it is an on-premises, whether it is a physical server. It is the same look and feel, same experience, nothing changes. Yes, the networking parameter changes. You're not supposed to go to TCP IP properties and make any changes. This VM will be unstable or you will lose access to it. So anything related to networking configuration, you will not do it under network properties. You will always do it under VPC plate or the virtual machine plate. So that's how your virtual machine looks like. Your virtual machine is available. Now, what we will do on this virtual machine, since we have enabled HTTPS traffic, I will quickly configure IIS, Internet Information Services, on this virtual machine so that I can show you that aspect also. So I'll click on Add Roles and Features. We'll wait for a minute for Server Manager to load properly. Typically, servers are created with a couple of GB RAMs, and then probably I would say 8, 16 CPU cores. So they run faster. Since this is a demonstration, I'm just using a lower configuration to reduce the cost. So this is how you basically deploy IIS role. You select web services, add features. I'll also show you how we deploy Apache Web Services in a Linux instance after this. You just select it, select the default options, hit install. What it is doing, it is deploying web services into the server, as a result of which it will create a folder in the C drive with the name inetpub. Over here, a folder will be created, and inside that folder, you will deploy or you will host or you will store your web application, web portal, or any application data or files that needs to be accessible over the internet or within your corporate intranet. Okay, so we'll just wait for a moment to get completed. This will take probably a minute. All right, it's almost done. You can see the folder is created now. It says inet pub. Inside this folder, this is the folder where you upload the index file of your application, and rest of the files goes in the respective folders, or they go here in the root drive. So over here, you already have the default IIS start page that basically confirms the presence of web services on this server. So let this part get completed. How do you check whether it has been installed successfully? You can open a browser. The default is Internet Explorer on any Microsoft client and server operating system. You can just type here localhost. And if you see the IIS page, it means that the server is configured with web services. Yep. So it is configured with web services. This is not moving on. This is probably closed. This part was probably done. It was just the synchronization. So IIS is working properly. Now let's understand how do we connect to it. So we'll come out of the virtual machine. We'll come back to the portal. This is the IP address. We'll copy the IP address of the virtual machine. We'll put that into the browser. By default, when you put an IP address into the browser, it will try to make an HTTP connection to that virtual machine, unless you specifically mention the port by putting colon. So you can put colon and mention the port, and then it will try to connect to that port. If you don't mention anything, it will try to connect to the port 80 of that server. So now you can see I'm getting the response from that server over the internet. I am trying to access the server from my personal laptop, and I'm getting the response. So what it tells me that the server is hosting web services. I can go ahead and deploy an application on the server, and it will be accessible to the rest of the world based on the configuration that you will do. So that's the Windows part. Now let's go back to the firewall to understand those two checkboxes that you did, that what those two checkboxes basically means. So we'll navigate to the virtual machine. There are two ways to do it. Either you navigate to the virtual machine and from there you navigate to the firewall rules, or you can directly navigate to the VPC firewall and you will see the configuration. So here you can see what it has done. It has created two tags, HTTP server and HTTPS server. This is what it has done. And if you go to the firewall rules in the VPC, you will see a mention of those two tags now. So this is the VPC where the VM resides. If I go to the firewall, if I look at the firewall rules, here you will see the rule for those two here. So okay, over here, this rule and this rule. These two rules, the first rule and third rule, is created when I check those two boxes, which is HTTP server and HTTPS server. And this rule is basically allowing traffic from internet. And if you want to see that this is allowing traffic on internet to the destination, over here. So here it is allowing the traffic from internet, and it says it allows the traffic from the internet on targets that have these network tags associated with them, HTTP server and HTTPS server. So this is what happens when you check those two boxes. for the first time, it will create a network tag. If you check both the boxes, it will create two network tags, HTTP server and HTTPS server, and it will create a rule in the firewall and an inbound rule in the firewall, ingress firewall rule, to allow all traffic on port 80 and 443 to all the servers who have those tags allocated to them. Now, in future, if you provision a new virtual machine, additional virtual machine, and check both the boxes, it doesn't mean that it will create a separate firewall rule for them. No, the same firewall rule will remain applicable to everyone now. To all subsequent instances that you will provision, the same firewall rule will remain applicable. I'm sorry. Even if you don't enable the firewall rule, and while provisioning the instance, if you directly go to advanced settings, go to VPC network, and if you put this tag, which is HTTP server, HTTP-server, or HTTPS-server, the same firewall rule will apply. That's the concept of checking those two boxes. Rakesh, I hope this answered your question.
Yes, yes.
Great. Any other question, guys?
So can we like give a user to access these VM only? Like we are assigning this VM, we can give permission to one user, they can access.
Yeah, you can do that. For that, you need to use identity and access management part. I'm saying you can assign, you can create. So you have IAM roles, you have preset and custom roles. So you can either assign a user access to a role that gives user access to all the virtual machines, all the compute engine instances, or you can create a custom role when you can define the VM to which user will have access to only. See, similar to Azure, in Azure, you have the concept of resource group. So you provision resources inside the resource group. Now, and let's say the resource group contains a VM. So what you do, you navigate to that resource group, you right click on it, or you select the IAM portion of it and grant access. Whosoever you grant access will have access to that VM. Or you can directly go to subscription, go to IAM, and you can select compute a virtual machine contributor role. And the person gets complete access to all the virtual machines. So whether you want a blanket access to all the compute engine instance, or you want a specific access to a specific compute engine instance, it is the IAM capability that you will use. It has nothing to do with the compute engine dashboard. Okay.
Okay.
Any other question, guys? All right. So if we don't have any questions, this is how we provision a compute engine instance in Google Cloud. And this is how we manage the network aspect of it. I've also shown you the connectivity part. I've also shown you how do we deploy a web services on a compute engine instance, and also how do we access the compute engine instance over the internet or the web services over the internet. So that was the part from compute engine Windows perspective. Let's understand the same thing from Linux perspective, and then comes the monitoring part. So from tomorrow onwards, we'll talk about monitoring, because we would have understood the configuration part, then we'll look into the monitoring part. So let's understand the Linux part also real quick. So if I want to provision a Linux instance, all I need to do, so what I would rather do, I will show you all the options, and then I already have a Linux instance here. I will reuse that instance, but I'll show you all the options. So I'll click on create instance. The same configuration comes, which is name. So I can say testing Linux. I can select my region, the same region. Zone I can select B. Machine size will remain the same. Since Linux is a light operating system, I would rather select E2 small instead of medium. This small can easily handle my virtual machine. Rest of the options are same. There is no challenge, no change here. You can see it is the same options. I'll directly move to boot disk. Here I can select Debian as one of the Linux distribution, and I can select the latest version, which is Debian GNU Linux 12 Bookworm. Disk type will remain the same. You can change the disk type if you wish. Now, one thing to notice here is Linux operating system requires a minimum storage capacity, and that differs from one version of Linux to another. So Debian uses 10, while Red Hat may require 20 GB, but between it will always remain between 10 to 20 GB. So I'll go with the default and I'll select it. For identity and access, I'll go with the default service account. And for this instance also, I will enable allow HTTP and HTTPS traffic. Then comes the observability that we will discuss tomorrow, the monitoring part. In the networking, I will see I'm not selecting any network tag. It will automatically pick up the tag based on the checkboxes that has been enabled. I'll just select the network. The subnet will always automatically be selected because that's the only subnet in that VPC, in that region basically. Rest of the information will be default. I'll just go with the default options. Network service tier, I'll keep standard. Disk and rest of the options will remain the same. So I'll provision this VM. So this is the Linux VM that gets provisioned, and Linux is very quick. It will hardly take a minute to get provisioned. So we'll just wait for a minute. All right, Linux is done. I need to connect to this instance. Now, you can SSH to a Linux instance using third-party solutions like PuTTY, WinSCP, or you can also use Google Cloud. What Google Cloud does, it directly provides you access to Linux instance, SSH instance. So all you need to do, just click on SSH here, and you can see it will open a browser. It's a browser-based SSH access, which is quick and which provides the similar capability that you would have experienced using PuTTY. So what it is doing, it is basically transferring the SSH key to the VM. And for that, it might ask me to authenticate myself because I'm using an incognito window. And in incognito window, it doesn't use cookies. It doesn't store any configuration from user. However, if you're using a normal browser, it will not ask you this information. It will directly allow you to SSH. So I'll click on authorize, and you can see it is opening that window. So it is authorized. I'm logged into my Linux server. I'm on the command prompt from where I can start working on Linux. Now, this is not a Linux training, so I will not get into the details of how do we manage Linux operating system, what are the default commands, or what are the typical administrative options which are there. We're not getting into that. We just want to understand the compute engine part. So after your machine is provisioned in console, you can directly connect to that machine. Browser-based SSH option you can access, you can create. And once that part is done, let's see how do we deploy web services on it so that we can understand the firewall part also. So the first thing that you do after logging into any Linux distribution is to update that distribution. Sometimes the image that cloud is holding is not up to date, and you would like to make sure that your distribution remains up to date. So for that, we can type the command, which is sudo apt get update. And this will update the Linux distribution. Anything new which is there in Debian, the package will get downloaded and installed. So it is updated. Then the next command is to deploy the Apache web service on it. So in order to deploy Apache web service, you can type the command sudo space apt get install Apache 2 and PHP. That's it. So what it will do, it will download the package from Apache and it will deploy. It says that it will take some 29.7 MBs of additional disk space. Are you ready for it? I'll say yes. I'm okay. Take it. Now it is downloading and installing the Apache services. Done. It has done deploying the Apache services on the VM. And how do we make sure that these services are up and running, it is working? We can follow the same process. We can capture the public IP of this VM. We can put that into the browser. If we get response from the VM, we will see the Apache homepage. If it doesn't come, then we will need to troubleshoot. First, we will troubleshoot from inside the VM to check whether Apache services are up and running. And then we will troubleshoot it from network perspective that why the VM is not receiving traffic, for the Apache services. So I'll just minimize it, copy the public IP, which is here, and I will put that public IP into the browser here. I'll say HTTP, put the public IP, hit enter, and there we go. So we can see Apache to Debian default page, which means Apache is installed and configured on this VM properly, and you're able to access it over the internet also. Next is to hand over this VM to your application team, who will then deploy the application. Or if you know how to deploy the application and configure it, you can also do it. Now let's understand the firewall part here also. So if we go back to the firewall once again, before we go back to the firewall, let's go back to the VM instance and see whether it has created some additional tags for the VM. So I'll select the VM instance and the same networking page where the firewall, you can see that it is also using the same network tags, which is HTTP server and HTTPS server, the same network tags. Now we'll navigate to the firewall and we'll see, is it creating separate networks or the same? We'll go back to we'll select the VPC in which the VM resides. We'll click on the firewall. And here you will notice that it has not created a separate rule for it. In the same rule, this also applicable to the same rule. So here you can see allow inbound HTTP internet, and no, not this one. This is web server. This is the one that I have created actually. This is the one. These are the two rules you can see here. And how do you know that these are the rules? From the network tag. You can see HTTP server, HTTPS server. These are the two network tags. So any subsequent VM that you will provision going forward in the same VPC, if you select allow HTTP traffic, allow HTTPS traffic, it will embed the same network tag, which is HTTP-server, HTTPS-server to the VM, so that when the traffic comes on the VM, firewall knows that, okay, I need to forward the traffic to the target which has this tag embedded on it. So the traffic will directly reach the VM and users will be able to access the application from the VM. So that's the concept of provisioning compute engine instances in Google Cloud, both for Windows and Linux, along with deployment of web services and then having those services accessible over the internet. I'll take a pause here and see if you have any questions before we move on. Any questions, guys, on the provisioning part? All right. If there are no more questions on the provisioning part, let's understand in the remaining time, let's understand the configuration changes or the administrative use cases or the call drivers that you typically handle when it comes to compute engine instances. What are the typical requests that you will expect to come to yourself while you work in a project wherein you are responsible for managing compute engine service, managing and providing support. So let's navigate to that. So if I navigate to VM instances, I will see all my VM instances in this dashboard, which includes Windows and Linux. And I've told you how do you identify by looking at the connect option. Now, what are my options when it comes to troubleshooting? So when it comes to troubleshooting, these are the typical call drivers that you will find yourself dealing with. Give me a moment. Let me get the session transcript. So these are the common call drivers or common areas that you will primarily spend working on. See, when it comes to provisioning, you will not provision virtual machines all the time. Provisioning a compute engine instance. This will not happen all the day. You will not only provision the instances. Instance provisioning will happen once in a while. What you would do instance is to do the management and monitoring of it. So configuring ops agent and matrix and alerting. So you will configure the monitoring on the compute engine instance, which will involve deploying ops agent and then configuring the matrices, alerting, and also the custom dashboards. Now, this is also one-time job. You will not do that all the time. What you will do all the time is network-related activities. For example, allocation or deallocation of public IPs or ephemeral IPs, public IPs. This is what you will do. You will reserve static IP on the CE instance, compute engine instance. So this is from the network perspective. Then from security perspective, you will configure whitelisting TCP IP traffic whitelisting on the CE instance from the firewall in the form of network tag or in the form of directly creating a rule. That's what you will do from networking perspective. Then from day-to-day administration perspective or storage perspective, you will need to know how do we create, attach, update, delete disk on the CE instance. So how do you create a disk? How do you attach a disk, a new disk or an existing disk? How do you update the disk? Update the disk basically means how do you upsize? If you can start with, let's say, 20 GB of data disk. What if that 20 GB is getting exhausted? How do you make it 30 GB, 40 GB? That's what update is. And then delete the disk on the instance in the end. Then you will need to know how do we configure snapshots for disk. Configure backup, recovery, and disaster recovery for CE instances. Now, when it comes to disaster recovery, we typically configure disaster recovery for an application, but you need to understand application is nothing but a virtual machine in the backend. So you actually end up configuring it for virtual machines, the disaster recovery strategy, which are hosting your mission critical application. So configuring backup and disaster recovery for virtual machines. Now configure snapshot for disk, and then leverage a snapshot to provision a compute engine instance. That's what you will also do. So these are the call drivers. I'm just telling you from my experience of managing various projects and various assignments that this is what the typical call drivers are for team members who work in compute support. So you'll configure backup recovery, disaster recovery for CA instance. And in the end, you will also do a lot of troubleshooting connectivity issues. So there are times when firewall rules are supportive. The VM shows as up and running into the portal, it shows green. Everything looks normal, but still users are not able to take remote or SSH into the virtual machine. So you will configure troubleshooting, you will troubleshoot connectivity issues by creating connection trail. That's what you will do. So you will configure troubleshooting issues, and then this backup and recovery that you have done, you will also perform regular DR drills for the virtual machine so that you're 100% sure that when you actually need, you can say you will perform backup and DR drills. Even though the machine seems to be up and running, you will once in a quarter, or let's say once in 6 months, you will bring that machine down, try to reconfigure the machine, recover it from the backup. You will immediate as if disaster has happened, and you will perform a disaster recovery strategy. You will execute the disaster recovery probably in an isolated environment to simulate DR end to end, and that will also serve as a evidence for the audit that will happen for the firm or for the customer that you are supporting. So these are the typical operations that you will do. There are some additional operations from the network perspective, which are very rare, which is moving a CE instance from one subnetwork to another subnetwork within the same VPC. The other is moving a CE instance from one subnetwork to another subnetwork across the VPC. And then also one more, which is moving a CE instance from one region to another region. And when I say another region, it is within the same geographic location as well as across geography. These are additional things that you can think of working, but these things comes very rarely. This is not something that you will do every day. This is, I would say, this happens very rarely. These are the things that you will do almost every day as part of operations whenever you start supporting Google Cloud projects. And this is basically from compute perspective only. So these are the typical operational aspects that you will work on. I'll just put that into. Okay, one more thing that I have forgot to mention from security perspective, which is dealing with configuring and troubleshooting access issues, connectivity issues from networking perspective, access issues from identity and access management perspective, and then configuring and troubleshooting access issues related to encryption. So sometimes what happens, virtual machines and disk are encrypted using a cloud KMS key. There is a principal who wants to access the machine or the data which is stored inside the disk of the machine, and they're not able to access it because they don't have access to the KMS key in order to decrypt the data. So you will see those issues also, wherein you will need to add those principles as users in KMS so that they will be able to access it. So configuring and troubleshooting access issues related to encryption. And this one is related to, I would say, IAM. And this troubleshooting connectivity issues related to security and networking. That is all, guys. I don't think of anything else related to common call drivers for a compute engine service. Then you have one more, which is the operating system level troubleshooting. Definitely, this is outside the purview of cloud team. It cannot happen that you are, I'm saying it may happen depending on the project also, but most of the time what happens, you are only managing the cloud portion, and then there's a separate team who's responsible for managing the operating system. So whenever it is something to do with cloud-based configuration, you will handle it. And if it is something to do with operating system, you will probably collaborate with Wintel or Linux admins. So they will take care of operating system internals and you will manage the machine from cloud configuration perspective. So that's how it happens. So those are the call drivers that you will find yourself working with when you start to support compute engine service in a production environment. I'll take a pause here and see if you have any questions on this.
So what about patching? Patching will be part of this, or do we need to have a separate?
See, for patching, as I said, that's the job of the operating system team. You will not perform patching. Typically, see, when it comes to a production environment, you don't patch individual VMs. You patch VMs in a collection, in a group, and that group is created by Wintel team based on the mandate from application. So you have a separate group for production servers. Now within production server, you will have multiple groups depending on the application environment, depending on the department that it belongs to. So patching is typically the responsibility of operating system administration team, not the cloud admin team. The cloud admins do not get involved into patching. Their job is to support patching, which basically means that patching will happen as part of a change request. And when that change request is executed, there will be a representation from cloud team also. So that if there is anything that untoward happens, let's say a compute engine instance is patched and that patching corrupts the instance, then the cloud representative will be there to probably recover that instance from a backup or from a snapshot that was taken right before the patches were executed on that machine. So it will be a coordinated activity between cloud team and in the operating system admin team. But it doesn't happen. I've not seen that in any project or at any customer where patching is being performed by the cloud team independently. Hope that answers your question, Madan.
But here we are doing patching. As a cloud team, we are doing patching. So like in Azure environment, we are doing it WSCS server is there. Like we are getting a patch report from WSCS server, and we are pushing update through automation account.
Yeah, that's what I'm trying to say. That probably that project is not that large, or your project, I'm saying, expects you to be a multitasking person, multi-talented person, wherein they also expect you to do patching other than managing the operating system activities. So you're doing patching. What if let's say, what if ADFS or SSO needs to be configured for an application? Who does that part? Are you doing ADFS or SSO configuration? No, that OS team is doing. Probably the client has internal OS team who is responsible for it, and client has given you the patching responsibility. That's how it is. So the responsibilities are being distributed. So you are getting the patching responsibility. Other than patching, if you refer to that specific project that you're part of, you're also doing vulnerability management. You're also handling additional responsibilities. So it is part of the scope. But in a production environment, where there is no customer, when there is no support team, there are separate teams who manages it. And in a support environment, anything can happen. Okay.
Okay.
Yep. We have met the agenda of this session, wherein we did provision two instances, two compute engine instances, one for Windows, one for Linux. And we looked at all the configurations which are available in the portal. We also deployed web services and have the instances accessible over the internet to understand the networking part of it also. And then in the end, I summarized the common call drivers for compute engine services, or for a team that manages the compute engine service. You can use these call drivers as your starting point, and you can keep on updating this list and add more responsibilities based on what your current or upcoming projects expects you to do. That is all from my end, guys. Tomorrow, the agenda is to talk about the monitoring part of it. So we will reuse the same virtual machines that we provisioned today, and we will deploy and configure the ops agent on both the virtual machines. We will look at the configuration on both Windows and Linux. We will see how do we configure auditing, how do we configure alerting, how do we create a dashboard, how do we enable monitoring using the matrices. That is what we are going to do tomorrow, which is primarily be focusing on monitoring part.